per usual, just write down everything I write on here, and then afterwards I'll go around and give you credit for it. And then you can use these as a guide when you do your weekly ALEKs, and then also as a study guide as you prepare for the test. So over here, I just start with some of the vocabulary that we learned. We also have this chart on the board as well to help. It says select all that describe CD. So CD is this segment right here, CD, and then GI, this segment. While I'm highlighting, I'm just going to highlight all of them, and MN is what we're describing there. Okay, even though it says select all, I'm not sure why they said select all, because it's just select one. So for all of them, it's just select one, and there'll only be one correct answer. Okay, so then looking at these terms, which I know it's been a minute since you've seen, perpendicular bisector of AB. So perpendicular bisector, it's like this. It's perpendicular, and then it bisects this side, so like this is the same length as this. So that's what you're looking for when you're looking for a perpendicular bisector. This is perpendicular, it has that little square, but it doesn't necessarily bisect that side because it doesn't have those little marks that show like this is the same length as this. So this is not the correct answer there. Then angle bisector, it bisects the angle. So you'll see a line like this, and then you'll see these little arcs here showing that it's the same angle on both sides of that line. That would be an angle bisector. We don't see that here, so it's not angle bisector. A median goes from the vertex to the midpoint on the other side. Sometimes it's kind of like a slanted line like this, and then it hits at the midpoint, meaning this is the same length as this. That would be median. That is not the situation we have here. And then altitude is just perpendicular height. It doesn't necessarily bisect the side right here. And that is what we have here. So it's perpendicular, but we don't know if these two sides are the same length. So this is the altitude. Okay, then we continue that. We're not going to draw pictures every time, but now we have an example of each one. So perpendicular bisector, no. Angle bisector, yes, it shows these little arcs showing that it's bisecting that angle. So this is the answer here. It's not a median or an altitude. Okay, select one that describes segment MN. MN is perpendicular to this line, and it hits at the midpoint because it shows that these two sides are the same length. So this would be a perpendicular bisector. Not an angle bisector, not a median, not an altitude. Okay, actually, if we're going to do 2 lines, then we'll do 2 lines. Okay. Then also at the top here, I have this little chart just to kind of review the vocabulary. Perpendicular bisectors intersect at the circumcenter, and that's equidistant to the corners. And we'll look at that with the pictures too. Angle bisectors intersect at the incenter, and that's equidistant to the sides. Medians intersect at the centroid, and that breaks up the segments into 1/3 and 2/3, or a 2-to-1 ratio. And then altitude intersect at the orthocenter. And then the hack to remember this is peanut butter cookies are best in milk chocolate and Ovaltine. So if you can get to a point where you can just remember this sentence in your head and be able to write down peanut butter cookies are best in milk chocolate and Ovaltine, then when they say where do altitudes intersect, you could just be like, oh, it's the O word, orthocenter. The only conflict here a little bit is the 2 C's, but perpendicular bisectors intersect at the circumcenter, and then medians are centroid. Okay, so we have this up here if we need to reference it. You guys got that done. Then down here, we're going to start with centroid. So medians intersect at the centroid, and then it makes 2-to-1 ratio. So medians, centroid, and then it's a 2-to-1 ratio. So what that means is this is a median here, and then that hits at the midpoint here, so that's the same length as that. This is a median here, and this is the same length as this here. And then this here is a median, and then this would be the same length as this. Okay, and now we're going to look at what they gave us and then just fill in whatever we can as we go. So it says BU is 10, so this length is 10. This is a shorter side and it's in a 2-to-1 ratio, so we can just double that to find the length of this. So that would be 20. Then VS is 7. So this here is 7, and that's the shorter side of the median, of this median, so we can double that to get this length. And then PT, from P to T, it's saying it's 21. So to get each part of this, remember it's like 1/3 and 2/3, so we can do 21 divided by 3 equals 7. So this is short side, and then we can double that to get 14, this length here. Then once it's all labeled, it makes it really easy just to answer the questions. So PV is 14, QV is 20, and then RS, 7 plus 14, is 21. Okay, then from there, let's go up here. So here, using circumcenter. So we have perpendicular bisectors intersect at the circumcenter, and then the circumcenter is equidistant to the corners. So if this is circumcenter, then the distance to the corners is all the same. These 3 lines are the same length. And I'm going to label what they tell me. So UV is 54. So this is 54 right here. PR is 142. So PR 142. And since these are perpendicular bisectors, like this is the same length as this is the same length as this here, 142 divided by 2 is 71. So this would be 71 and this is 71. I'm just filling in what I can figure out from what they gave me. And then RV is 90. Let's see, RV is 90. And that is one of the distances from the circumcenter to the corner. So all this is the same, 90 and then 90. All those are the same. Okay, so let's look at this. I'm going to do these two first because they're a little bit easier. SR 71. I already have that filled in. QV right here is 90. Because the distance to the corners is all the same. And then PU right here, I have to solve for. I'm going to call it B because in order to solve for that, I'm going to have to use Pythagorean theorem. A squared plus B squared equals C squared. By the way, this is just 90. This little tally just shows that this is the same length as these two. Okay, so I'm going to do 54 squared plus B squared equals 90 squared. And then solving this here, 54 squared comes out to 2,916. 90 squared is 8,100. Then subtract 2,916 from both sides. B squared equals 5,184. And then square root, and B equals 72. So PU is 72. And of course, make sure it's logical. It shouldn't be longer than the hypotenuse. It makes sense if it's a little bit longer than this side here. Okay, then we'll move down here. Using the incenter of the triangle to find segment lengths and angle measures. So angle bisectors intersect at the incenter, and then the incenter is equidistant to sides, equidistant to sides. Okay, so it's saying that this is the incenter. That means that these are angle bisectors. So this is the same angle as this. Like these are bisecting the angles. So this is the same as this over here. And then this angle is the same as this over here. And then also the incenter is equidistant to the side. So this is the same length as this and the same length as this. Okay, now I'm going to fill in what they gave me and figure out what I don't know. So WZ is 10. So this is one of the ones that are equal to these two. So if this is 10, then this is 10, and this is 10. It says RZ is 19. And then WQX. WQX, so this whole angle is 96 degrees. And YPZ is 18 degrees. Since this is an angle bisector, if this is 18, then this is 18 degrees. And then we'll look at what they're asking for. So it says, what is a measure of YPW? YPW is this angle. Well, these are both 18, so 18 plus 18 would be 36 degrees. So we get 36 degrees here. It asks for the length of XZ right here. We have it labeled as 10 because the distance to the sides from the incenter is all the same, so it'd be 10. And then it asks for YRZ, so it wants this angle right here. The way we can figure out that angle is just 180 minus this angle, minus 96 minus 36. That comes out to 48 degrees. So this whole thing is 48 degrees. And then this is an angle bisector, so we can divide 48 by 2 to get each of those. 48 divided by 2 is 24 and 24. And so YRZ is 24 degrees. And then we have one more up here that we need to look at. Okay, everybody have that down? Okay, so this one here, Introduction to Triangle Midsegment Theorem. What you need to know for this is each of these are midsegment. So this right here is a midsegment, and with that midsegment, it hits at the midpoint here and midpoint here of this side. So this is the same length as this, and then since this is the midpoint here, this here is the same length as this. This midsegment right here corresponds to the side that it's parallel to. So this here, parallel to this. So it says here that DE is 32. And then the midsegment is half of the length of the side it's parallel to. So this is 32, then this here would be 32 times 2, which is 64. So this whole thing is 64. But this here is also a midpoint here. So like this is the same length as this. So each part of this would be half of 64, which is 32 and 32. So essentially all three of those segments are the same. But the whole concept is the midsegment that's parallel to this base is half of the length of this. And then that applies to these two. So this here is a midsegment that corresponds with this. So like this is parallel to this. And then it says BC is 58. 58 divided by 2, 25 is 29. So this is 29, this is 29, and then this would be 29 because it's half of this length. And then this midsegment corresponds with this side. Well, the AB right here is 36. So then this would be 18, 18, and 18. And then from here we can answer the question. So AC, A to C, 32 times 2 is 64. DF, D to F is 29. And CF is 32. And that's just okay, so what I want you to do is leave this out so that way I can run and grade it. Then you're going to start your assignments on ALEKs. I would recommend starting with these assignments just to get your brain warmed up. They're a little bit easier and can just like maximize your points. And yeah, let me know if you have any questions.